Hi. Now if I had a vector A, say, and then I took that vector again and doubled it, put another vector on it, I get a vector 2A, twice as long as the previous vector A, going in the same direction. So what we can do is replace these two vectors with the vector 2A. If I did 3A, it would be to clearly put another one of these vector A's on the end here, and so on. What we're doing is multiplying a vector by a scalar, in this case the number 2. Now suppose the vector A was, say, 3i plus 2j. Then if I've got it in component form, or even as a column vector 3, 2, we can multiply a vector by a scalar. So therefore, if it was 2a that we were talking about, I just need to double the components and I would get 6i plus 4j. Or as a column vector, simply 6, 4. And we can do the same with vectors in 3 dimensions. If I've got a vector b which was 5i minus 2j plus 3k, and I wanted to treble this vector, say 3b, 3b would clearly be 15i minus 6j plus 9k, and so on. Very easy idea. Now we can also do addition of vectors. If we have two vectors, say a and b, when it comes to vector addition, it's like taking our vector b and putting it on the end of a. So we have really what is called a followed by b. And this particular vector, a followed by b, is a vector from here to here. And it's called a plus b, a followed by b. It's not the normal addition that we might think of when we do, say, 3 plus 2, which equals 5. No, this is something different. Think of the plus as followed by. So we're doing this movement A followed by this movement B. And it's equivalent to going from here to here. So A plus B. We can also do subtraction of vectors. Suppose we took our vector A and just moved it over here. Let's just write on that that's the vector A. Now if we take our vector B but take the negative of it, that's this vector here, bring it over to here and put it on the end of A, this vector then is minus B. We'll just write that on. It's going in the opposite direction, but it's the same length as B was. Then what we're doing is A followed by minus B, A plus minus B. It takes us from here to here. So I could write then A followed by minus B, but we prefer to think of this plus minus, just replace it with a minus, so we have got A minus B as this vector. Now if A was, say, the vector 3, 2, minus 1, or 3i plus 2j minus k, and B were the vector, say, 4i, 3j, and 2k, then we can add and subtract these vectors. Just simply add or subtract elements in the same position. So A plus B would be equal to 3 and 4, which is 7 in the I direction, 2 plus 3, 5, and minus 1 plus 2 is just going to be 1. 7i plus 5j plus k. Or if it came to subtracting the two vectors, A minus B, all we need to do is just do 3 minus 4, which is going to be minus 1, 2 minus 3, another minus 1, and minus 1 minus 2 would be minus 3. Minus I, minus j, minus 3k. And you can write them as column vectors or in component form with i's, j's and k's. Up to you. Okay? Well, I hope that gives you some idea of multiplying vectors by a scalar and adding and subtracting vectors. Now what will follow is a few video examples where we use some of these methods discussed here. So I hope you'll have a look at those and find them useful.